Hey, hello there. This is going to be a build tutorial for a procedural intersection weld, as you can see here. In a previous tutorial I spoke about another one that I did. This was the latest one, but I couldn't get the UV mapping quite right on the seams, so it didn't look right yet. But now I think this is a big improvement, because now you can really see the individual dots that are being laid down when you weld, and it's a lot more detailed and a lot more accurate as well. So what you have here is the weld seam, and we can also set the weld sharpness. If we set it to 0.5, it's not sharp at all. If we set it to 0, it flips into the other direction. If we set it to 0.8, it goes into the other direction as well. We have the iridescence that we can change. So if we put that to 0, it will take the color. Here we can set the color. Let's put it on red. Like if it's some kind of aluminum weld, you can give it certain colors based on the temperature that you're using for your weld. If we set the iridescence to 1, it's really colorful, as you can see. And if we put it back to 0.5, and the roughness is just the roughness and shininess of the material. So it becomes more shiny or more rough when we change this value. So you may ask, how do we build this? Well, the quick version, if we go into geometry nodes, this is basically what we're doing. If you want to build it quickly, here is the smooth remesh that I'm using here. And then I'm adding some particles on the sides. So it's little weld imperfections. Here I set an extrude and a thickness. And here I'm storing all the attributes for my material. So if we go into a new file and build it ourselves, then you can follow along. So let's say we go into this file. We're taking all these. I made more tubes here to intersect, and if I put them into the tubes folder or collection, they will be used to create the intersections. And also I have another one for burn marks, and the burn marks is creating these colorings on the object themselves. So when you weld, you also have temperature shifts, and that's why you get these rainbow-like colors there. But here you can see for all the tubes, like it works pretty well. So if we go into this folder, and let's take these 3 objects, and I copy them over to my other file. Set this objects, and then drop them in. There we go. And now we're going to use these objects as intersections. So this is going to be our weld geometry node, and we pin it. Let's import all these objects into our nodes and then put them in the output. Turn this one off. You still see them because they're here. And now we need a mesh boolean. And we set the mesh boolean to union, because we're going to merge them all together. Now they disappear because you have to separate all the separate objects in the folder. And now you see that by this weird smoothing groups that they have merged. You can also see it in wireframe mode. Here you see that they really intersect. And now it's one object. And now we can get the intersection line that we are going to use for the weld. So let's do that quickly. We use a delete geometry, set it to edge, we put it in, and if we use this one, you see that it does the other way around. Now we need a knot to flip the selection, plug it in, and here we go. Here we have the intersection lines. So these are going to be our welds. Now the next thing we are going to do is we need the normals, because if we create this mesh to curve, It's a little bit slow still, so let me take out the tube for now. So it's going to be a little bit faster. So mesh to curve and then curve to mesh. And then curve line. So what we're going to use here, we set this to 0.1 and 0.0 minus 0.1 I need. When we plug this in, you see now that there is a panel made or a ribbon, and the normals are not quite right, because if we do this, now what we want is that the surface is coming out in the right angle, and it is the angle of the two objects actually. And what we can do if we use this mesh boolean, so these are the objects, I'm going to sample nearest surface and I'm going to make it a vector. We use the normal, so we want to get the normal of this line. So my surface that we create here is going to come out. And first you're going to see that it's not going to work because we have to do something to our mesh boolean still. We can set the curve normal over here, set it to 3 and then use the normal. And now you see something really strange is happening. What we also need is with the mesh to curve, resample the curve so you have a little bit more resolution to work with. Set it to 0.05 maybe. Now this is really becoming a mess, and why that is happening is because if we plug this in, like the normal, it's really hard for this line to be calculated where the normal goes, because it's two surfaces and they can both be just the nearest one, so that's why it's jumping around. So what we need to do is, or what I did in my example, is go mesh to volume and then volume to mesh, then put them both to size. We create a value to drive the size, set it to 0.1. We're gonna tweak this, it's probably not 0.1, but if we do voxel size, let's turn this one off to see what happens. So this is quite rough. We need more resolution, so 0.2 maybe. And here now you see that the this becomes smooth. So it's already looking a bit like a weld between the two parts. And this is what we need to calculate the right normal. So now it takes the nearest surface, and now the normal is really nicely pointing outward. So if we put it maybe to 0.1, then we have more resolution. What I also did was a set position and use a blur attribute. Set it to vector. Use a position to drive this. And set the position to smooth all these lines. And I put this one to 30 or something, maybe a little bit less, 20. And now we get a very nice normal to use here. So if we put this one a little bit up over here, now we're going to make this the driver of our sample nearest surface. And now we plug this in. Let's see what happens. Now this is already a lot better. The surface is maybe a bit too wide. Let's go to 0.5. This one also to 0.5. And here you can see that it correctly takes the normal. It's still a little bit jagged, but we can also solve this by a set position, and then we use also the blur attribute and the position to smooth it out. That's a little bit much. Maybe 1. Here you can see that it's becoming smoother and smoother. And maybe we need to give this a little bit more distance. As you can see here, this. And if we look at our mesh, now it's not quite correct yet. And that's because it's this line or the panel is being generated on the intersection lines. And we need to make them come out. So what we can do is make another set position node. Then we use the normal. And we multiply the normal. So we're actually creating a displace modifier. And if we use it in the offset and put it to 0.5 maybe, we should put it to minus 0.5. And now it comes out. And now probably it's too smooth. Yeah, this is beginning to look a lot better. Now, what I also did was use another set position. We use this geometry and use a geometry proximity. So we take the closest point, the closest face, and we use that position to set the points of this weld back onto the mesh. So if we do this, you see that it will snap to our mesh. And now we have a fairly nice ribbon that's going all around. And if we go here, faces, now you see it looks quite nice. We can also change the resolution a bit. Maybe what happens if we make it bigger? It becomes less accurate. We make it a bit smaller. It becomes more accurate. And this looks pretty well overall. Now, this is the part of creating the weld. What we also need is the UVs. So we can map a nice texture over this. And how we do this is we create or we use the curve line and the intersection curve, and we're going to map them to an XY coordinate, and we do that by taking the parameter, so the spline parameter, and spline parameter is when you use the vector, it goes from 0 to 1 all the way around, and when you use length, it's going to use the length, and it's just going to accumulate. So 1, 2, 3, 4, 5. And with vector, it's 1, 0.1, 0.2, until the end, and then it's 1. So you can use these both to map your texture in any way you want. So if we go and we capture those, capture. Oh, this is the wrong one. Capture attribute we need. And we use them in between both of these because we want to have the vector of this one. So the curved line is going from here to here, and this is going to be 0, and here it's going to be 1. And in this direction, I want it to accumulate. So it's going from 0, 1, 2, 3, and that's important for how it will stretch the texture. We delete all this. Now we do a combine. And with this combine, we can combine the X and Y coordinates. Give it some time to calculate because the Boolean makes it a bit slow. And then we store the attribute. No, store named attribute. And for this one, I'm going to choose the 2D vector and the face corner, as in all UVs. If you use a 2D vector and you would convert this geometry nodes Weld, it will see it as a UV map automatically. So let's plug this in. And now I'm gonna clean it up a bit. I usually don't want my lines to intersect too much, so it becomes clear when you want to change things or update things. And this is the Weld UV. And now we also need a material for it. Set material. Here we go. Do we have a material? Let's use material 1. That's standard. When I open my files, go into shading. Let's have a look here. To Eevee or pre-rendered mode. Then we go to object. We choose the material. We are going to call it Weld. And over here it's called Weld as well now. And we're going to use the attribute Weld UV. And let's say we create an image texture. Make a new one. Make a color grid. I like that one the most. If I plug it in now, you will see that nothing is happening, but when we use the right coordinates, still nothing is happening. I did something wrong here. Weld, 2D vector, float. Oh, I need to plug this one in as well. I forgot that one. And now you see that it works. And also when we look at these values, and for example, we change it. Here you can see with a factor. This one I wanted to have the length. So if I add, it is going to slide, and if I multiply, it's going to be squashed. Or if I multiply by 4, you see in this way you can stretch it. And with using the factor, it's using the whole image from top to bottom in this direction. And in this direction, we want to be able to make it slide. That's what I showed you, that we can change the sharpness of this. We can change how the weld looks. So let's not use this one. Also, what I'm going to do, because here I am using the proximity of the smoothed mesh, and actually I should put in the not smoothed mesh. So it's going to be a little bit wider. It's going to stick to the, if I'm going to look at with a viewer node and then turn off the objects, we're using the sharp one instead of the smoothed one. And that's why we get a slightly better result when we do this. Okay, and now we need to create the material for it. And how I did it was I created a gradient and I mapped it over this side. With a color ramp. So let's make this the gradient. See where it goes. Maybe with mapping I need to rotate it like this. And then here you can see, there it is. And if we do this, create another white one. We want to have this one in the middle. I need to put this at 1. And what we can do now, if we have any image, I can use this to displace the coordinates. So if I have this as an image and I'm using another mapping, And then what we can do for the location, I think I need a, let's just plug it in, see what happens. Yes, you see that it's having the point here, but it's quite prominent. So we can use a mix node, put it in the location, and then put this one to black. And then here you can see that I can make it more or less pointy. And maybe, well, this is fine. We can change this to ease, for example, so it becomes a little bit more like a wave. And here you can set how pointy it is. And this way you can use an image of a weld. You can change all your parameters here. I think what I did in the end to make it procedural was make a wave texture. Let's see how that goes. Yes, like that. Then put it into the vector. There we go. If we do this and we use a bump and then plug it into the normal, and we don't use this one, make it metallic, roughness maybe 2. This one should be plugged into height, and then here set the scale of our weld. Also, what we usually want to do is make it smoother, so you can use a map range for it and set it to smoother step. Then you get a little bit smoother edges. Maybe this is also way too high. Put it to 2. And a float curve can also do a lot of things. If you use a float curve and you make it not so flat, smoother step. If we do this, here you can see that you can make it like the weld is going to be sharp where they overlap and less sharp in the top. So this is how you can do it. You can also maybe add more of a wiggle, distortion here to not make it look too digital and generated. What I also did here was add an extrude. And this is going to go crazy because it uses individual and we don't want that. And then we set it to 0.1. Hey, now it's all the way gone. 0.001. Maybe the other way around. There we go. 0.3. So it comes out slightly. Now it has a little bit of volume, and when we do a subdivide surface to smooth it even more, now you see it's really like a ribbon with thickness that lays on top. If we mute this, you will see what happens. It's just flat. You can use it like this if you want, but you can also use it with a little bit of thickness. And this way you have a weld that works fine for a lot of things, and it's generated automatically. And it has a little bit of a wiggle here, a little bit imperfections, but that's what welds do. You can smooth it even more afterwards with a blur attribute. But for me, this is really looking nice already. You can add particle systems to add more imperfections, and this is basically how it works. So here you see the nodes again. So storing the attribute, the UVs. You can play around with the factor or the length here if you want to use different mappings. So we're using this boolean, and then just smooth and remesh this mesh and use the nearest surface, normal, and that's how it works. So let me know if this is useful, and see you in the next one. Okay, bye.